Hello guys, I'm a teacher Limboka Masame. Welcome to Limboka Physics. The question below states that on a wet road, the coefficient of kinetic friction between the road surface and the tire is 0.1. Two similar cars, A and B, are traveling at a speeds of 15 meters per second and 30 meters per second respectively. Brakes are suddenly applied to each of the cars. How far will each of the cars travel before coming to a stop? Consider two cars. This is car A and this is car B, and their respective frame of reference. This is A 0,0 and this is B 0,0 from the assumed center of mass of these two cars. Okay. For car B, displacement is x, and it is heading towards right of this frame of reference B, and its initial velocity is 30 meters per second, and its final velocity is 0 because finally it comes to stop or to rest, and its engine force as mass times accelerations. Its initial accelerations is AB, and it is heading along the x directions of the coordinates. And this is car A. Initial velocity is 15 meters per second. Final velocity as it comes to stop is 0, and this is engine force. And this is a normal reactions, and this is weight, and this is frictions that act left of this coordinate frame of reference, and also this is frictions for car B that acts left of this frame of reference. Okay, when we consider horizontal components of forces, we say that sum of forces in horizontal directions in x directions is equal to net force in x directions. This is for car A and respective for car B here. Okay, for car A, we know that the engine force that is heading towards a positive or right of A is always assigned positive, and friction that is pointing left of the A coordinates, it is negative, and this is mass times acceleration net, that is in A directions. Remember, these two cars, A and B, they are similar. Because these two cars are similar, we say that weight of car A is equal to weight of car B and their respective normal reactions, and also the friction of car A is the same as friction of car B, and also their respective acceleration. Engine force, we know for both cases engine force is 0, and therefore we remain with friction force that is equal to mass times acceleration for car A, and also friction force that is mass times acceleration of car B, the net acceleration. Okay, but from definitions, a coefficient for kinetic friction is equal to friction force divided by normal reaction, as normal reactions, as the friction force is equal to normal coefficient of kinetic frictions times normal reactions. But from vertical components of the forces, we know that normal reactions from reference 0,0 for both A and B, it is pointing up, that is positive, while a weight is pointing down, that is negative. It is equal to net force along the y directions. We know that along the y directions there's no acceleration, therefore net acceleration is equal to 0, and therefore R is equal to W. Then we substitute here, R now is equal to W here. Okay. For car A, we know that our W is equal to mg. Then we substitute mg, and it is equal to mass times net accelerations of car A, and the same as mass times net acceleration for car B. Therefore, net acceleration for car A is equal to negative mu kg, and also for car B is equal to negative mu kg. Therefore, our acceleration here, even if these two cars have different masses, but the accelerations will only depend on coefficient of kinetic friction times acceleration due to gravity, and it is negative because it indicates that this car decelerates, because this acceleration pointing towards a negative while this car is decelerating. It is in opposite direction with velocity. This is condition for decelerations. Okay, according to third equations of linear motions, that includes acceleration, displacement, and the initial and final velocity. Now we will have displacement y, that is equal to v square for A minus u square for A, and divided by twice accelerations A respective to B also, that is displacement x. Therefore we substitute the accelerations as 2 times mu of kinetic times g, and also the same as in car B. Then we substitute the initial or the final velocity, that is 0, and the initial velocity for car A is 15 times 15. Then here negative and negatives cancel out, and we have 112.5 meter, that is heading towards a positive of coordinate A, that is 0,0. That's frame of reference. And for B also, we know that is a final velocity is 0, initial velocity is 30 meter per second, because it is square, it is 30 meter per second times 30 meter per second, divided by 2 times the coefficient of kinetic friction 0.1 times 10 meter per second square. Therefore, we'll have 900 divided by 2, that is 450 meter, that is positive, that is towards the right of coordinate B. That's the frame of reference B. Okay. Therefore, it will take 112.5 meter and 450 meter for car A and car B, respective, to come at rest after applying the brake. Thanks for watching. Please like, share, comment. Don't forget to subscribe to this YouTube channel for more videos like this one. Thank you.